Hey everyone, so today we're going to talk about elasticity. This is a continuation of the supply and demand chapter. Now that you guys understand what demand is, what supply is, and how quantity demanded and quantity supplied are affected by price, we can go a step further and measure how much. Like, what is the actual relationship between them? We know that for demand, there's a negative relationship between price and quantity, meaning as we know that as price goes up, quantity demanded goes down. And we know that for supply, it's positive, that as price goes up, quantity supply goes up. But how much? If price went up 10%, would demand go down 10%? Would quantity demand go down 20%? Would it go down 5%? That's what we're looking at in this chapter, and that's what we call elasticity or price elasticity. Elasticity is really just a measurement of how sensitive something is to the change in something else. In this case, when I talk about price elasticity of demand, I'm looking at how sensitive is quantity demanded to a change in price. If something is said to be elastic, it is sensitive. If something is inelastic is rigid, it's not sensitive. Now, if I were to give you an example, medicine is something that is very inelastic. Why? Because even if the price of medicine were to go up, we would continue buying it. So there would be, even though there could be a very large increase in price, there would be a very small decrease in quantity. You see, quantity demanded does not really change that much because price changes. That's being rigid, being inelastic. But then if you take something like a sports car, even a small increase in price might cause a very significant decrease in demand. That's what we mean by when we say that something is elastic. It's very volatile, very sensitive. If I were to show you graphically, and I might be jumping the gun here. I'm pretty sure there's a graph somewhere in my thing, but compare these two things, okay? So you've got, let's say your supply, we'll just keep that as it is, and really what we're looking at right now is demand. And I'm going to copy this so that we're working with two very similar graphs, okay? But the only thing I'm going to change is the slope of my demand curve. I'll make this one really, really steep. Okay. Bear with me. What I've done here, I'm going to compare two identical changes in price. We'll call this P1 and P2, and it's the exact same point on both graphs. So, and look at the change in demand. When we go from P1 to P2 on the first graph, our demand changes by this much. But if I go from P1 to P2, which is the exact same price change, on the second graph, my demand only changed by this much. Think about that for a second. The same exact change in price causes a different change in quantity between these two products. Why? Well, this one is more elastic, so it's going to have a larger change. And this one is more inelastic, so it'll have a smaller change. This would be like your medicine example. That, okay, sure, the price went up, but I still need this medicine. And so, yeah, there's going to be a small change in quantity. A little bit, the quantity will go down, but not that much. Versus the sports car, where if you increase the price, look at the change in demand. It was pretty significant. That's what we're talking about today. So now to get more specific, here's your formula. Elasticity is really a ratio of the percentage change in quantity over the percentage change in price. The way we measure it is using this formula. We take the change in quantity divided by the average quantity. The little bar on top means average. Divided by the change in price over the average price. I don't know what this S is here. You can ignore that. Okay, so we're going to want to memorize this formula. Now, in terms of how to interpret it, whenever you get an elasticity that is greater than 1, and notice I'm using absolute values. The reason I'm using absolute values is that Your demand elasticity numerically will always be negative, but when you're interpreting it, you want to interpret its absolute value. So you'll often see us kind of ignore the negative. It's there mathematically, but as far as interpreting, we don't really care. So if you have an elasticity that's more than 1, we say demand is elastic. And what that means, there's 2 things to know. It means that the percentage change in quantity will be greater than the percentage change in price. For instance, you can have an increase in price of 5%, but that causes a decrease in quantity demanded of 10%. A bigger change in demand than the change in price, that means it's elastic. Now, in terms of expenditure is just how much people are spending on a product. It can also be interpreted as revenue, which is how much revenue the suppliers are making. It's the same thing. There is an inverse relationship that as price decreases, people will actually spend more money on these goods. When something is elastic, if you lower the price, more money will be spent. So for the company, if you look at it from the side of the supplier, if they're dealing with a product that is elastic, lowering the price would actually increase their revenues. And vice versa. Increasing the price would decrease the amount that people are spending, the expenditure or the revenue. I'm going to skip the middle one for a second. The opposite is the opposite. If your elasticity is less than 1, so you plug into this formula, you get an answer less than 1. This means this is what we call inelastic demand, where the change in quantity would be less than the change in price. So for instance, you might have an increase in price of 5%, but people are still buying it. So the decrease in quantity maybe is only 2%. You see how the change in quantity was less? So what happens here is that an increase in price would actually increase the expenditure or the revenue from that product. If you're dealing with something that's inelastic, like if you were making medicine, it's probably not ethical, but if you were to raise the price, you would make more money. Because, yeah, you're raising the price, but people are still buying. So the more you raise your price, the more money you make. And if you lower your price, you will make less money. People will spend less. And I have a graph on the next page that kind of puts this all together here. This is the expenditure graph based on, so the relationship between the total amount that we're spending, expenditure, which is just price times quantity, and quantity demanded. There is a point here where as people are buying more, you are making more money. But then you reach a point where if people continue buying more, you're actually making less money. Now that might sound weird. Like, how can I make less money if people are buying more? You have to remember the basic theory of demand. And for that, we're going to bring in that basic theory of demand graph. Okay, so you've got your demand. You've got QD here, quantity demanded in price. As people are buying more and more and more and more, what's happening is the price is falling. So you will get to a point where if you continue to increase the price in order to make more sales, you will actually start to lose money because you're lowering the price for everybody. And so, sure, you're selling more, but you're making less. I'll give you an extreme example. If your price is set to $100 and you only sell 2 units, well, price times quantity, you're going to make $200. Now, if you say, well, I'm going to decrease my price so I can sell more, and you drop your price to $20 and you manage to get 9 sales, you more than quadrupled your sales, but price times quantity, 180. You see? That means you've passed the point of your maximum revenue. And once you pass that point, the more you increase your price, the less money you make. Before that point, the more you increase your price, excuse me, this is wrong. Once you pass that point, the more you decrease your price, the less money you make. And before that point, the more you decrease your price, the more money you make. That's the relationship between expenditure and quantity demanded and price and all that. And that's why we say that your revenue is maximized at the price where demand is unit elastic. It is not elastic and is not inelastic. The elasticity is exactly one, where the change in quantity and change in price are equal. If you raised your price by 5%, your quantity demanded would fall by 5%. Okay. So that is the relationship. It's not super important, but it's something to know. So let's move on from this. The relationship between slopes and elasticities. Remember the extreme example I showed you? It was to prove a point. The steeper the slope, the more inelastic the demand. And the flatter the slope, the more elastic. And I've written that. You don't need to write it down. So steeper means more inelastic. Flatter means more elastic. And you've got some extreme cases. A perfectly vertical supply curve, or demand curve, but also supply, is said to be perfectly inelastic, completely inelastic, meaning that no matter what the price is, we will buy exactly the same amount. And if the demand curve is horizontal, we say that demand is perfectly elastic. Elastic meaning that the price is the same at every quantity. And if the price were to go up or down, you would have your demand would essentially disappear. Okay. We'll see examples of this, when we get to the different types of market structures. You'll have situations where demand is horizontal. The name for it for now is just perfectly elastic. Okay. Other little things that are less important, but still something to know. Factors that affect the elasticity. So there are certain things that will make you more elastic, more inelastic. So let's run through it. The availability of substitutes. The more substitutes there are, the more elastic you will be. The logic there is if you have options, you're going to be more sensitive when it comes to price. Think of something like a trip to Mexico. There are hundreds, maybe thousands of resorts in Mexico. And so if one of them were to increase its price, you have so many alternative options that you would look at that change in price and be like, not buying it. So you see, we would be very elastic or sensitive to a change in the price of something that has many substitutes. And on the flip side of that, something that doesn't really have any substitutes, well, what choice do you have? If you wanted to buy electricity, okay? Well, in every province or state, there's really only a handful, often just one provider of electricity. Let's take Quebec, for example, right? Hydro-Quebec. If you don't want to buy electricity from, if Hydro-Quebec were to raise their price, well, you don't have an option. It's not like you can buy from somebody else, so you're still going to buy it. You are not elastic in that case. Fraction of budget is a interesting one that's also super logical. Typically, things that are very cheap, you tend not to care about price. You tend to be very inelastic, not sensitive, because they make up such a small fraction of your income. If your favorite pack of gum went from $1 to $2, if you think about it, that's a 100% increase. That's massive. But it makes up such a small fraction of your income that you would not be fazed by this. Be like, okay, it's $1, whatever. Even though it's a 100% increase, you would not be very elastic here. You would not be sensitive to this change. But if we're talking about something that has a very large amount, that is a big portion of your income, a car, for example, if a car costs $50,000 and the next day it costs $100,000, this is the same thing. This is still just a 100% increase, the same as your pack of gum. But you see, I don't think I have to explain it to you. You can see that your reaction to that would probably be a lot bigger than the gum. You'd be like, oh, I'm not buying this car anymore. It's such a large fraction of your income that so all this to say that the more expensive it is, or the larger it is relative to how much money you make or you have, the more sensitive you're going to be to changes in the price. And then short versus long run. There isn't really a cutoff here. It's just a concept. In the short run, we tend to be more inelastic. If you needed to get to school today and the price of gas went up by 50%, that's the short run because you don't really have a choice. You're going to have to buy the gas because you need to get to school. But in the long run, you could say, well, maybe I need to buy an electric car. So when you have time to respond, you tend to become more elastic, more sensitive. So in the long run, you're going to stop buying gas because you'll have time to buy a different car. But in the short run, like today, you have no choice. So we are less sensitive to price when we don't have time to do anything about it. That's for demand. Now, we didn't really talk about elasticity of supply yet, but everything I talked about basically applies to supply as well. Suppliers are also sensitive to changes in price. You might have situations where there's an increase in price and then a massive decrease in supply, a massive increase in supply. So you can have a situation where, the percentage change in price is 10%. So the price of something increased by 10%, and then you have a huge increase in quantity supplied. Maybe the quantity supplied goes up 50%. It's the same thing. And so what are the factors that affect the elasticity of supply? Well, there's two here. Short and long run is the exact same. In the short run, we're more inelastic. In the long run, we're more elastic, exactly the same. And then ease of substitution. This one's a bit tricky. Elasticity will be higher if goods can easily be converted into a different product. So let's say you make t-shirts, and all of a sudden there's a change in the price of t-shirts, and t-shirts go down 50% in price. If you're able to do something else with that fabric, so I'll show you two scenarios, okay? Let's say we can make pants instead. What you would see is a pretty significant change in the quantity supplied of t-shirts. Maybe that would be 70%. So because t-shirts became cheaper, I'm not really interested in making t-shirts anymore, but I have an alternative. I can make pants with the same fabric. And so you're going to see a huge drop in the production of t-shirts in favor of making pants. But if you could not make pants, what are you going to do? You're not just going to sit on fabric. So you would still see a decrease in the quantity supplied of t-shirts, but it would likely be a lot smaller. This is what I mean by ease of substitution. How easy is it for us to do something else instead? If it is easy, the easier it is to replace it or to substitute this product with a different product, the more elastic the supply will be, the more sensitive it'll be. And the less options we have, well, then the more inelastic we tend to be, the more rigid. Okay, I hope that makes sense. If it doesn't, please ask. By the way, the price elasticity of supply is the exact same formula. You just use supply instead. So we'll do some examples now. Question number 1, the price elasticity of demand measures the responsiveness of what? The responsiveness of quantity demanded to changes in price. That's what we're looking at. How is the quantity demanded changing as a function of price? So the responsiveness of quantity demanded to changes in the price, the answer is D. If the price elasticity is 0.5, then a 10% increase in price. So remember what elasticity is. Elasticity is the percentage change in quantity divided by the percentage change in price. So if price elasticity of demand is 0.5, that would be this. That's 0.5. And we said that there's a 10% increase in price. So I'm going to make the percentage change for my price 10%. What would happen? Well, if you cross multiply here, you would have a 5% change in quantity. But what you need to remember is the theory of demand. The basic theory of demand is that quantity and price go in opposite directions. So you would have here a 5% decrease in demand. Very important, a 5% decrease. So 5% decrease in, not in total revenues, but in quantity demanded. 3. suppose that a quantity of a good, so I'm going to show you how to use the formula now. So remember the formula for elasticity is this one. Okay. So we were saying, suppose that the quantity demanded of a good rises from 90 to 110. So this would be your quantity stuff. So we're looking at the change in quantity, which is the change from 90 to 10. Change in quantity would be 20 units, and the average would be 100. Remember, to do an average, you just take the two, add them up, divide by 2. Okay, this is my average quantity. And then you do the same for price. The average price went from 120 to 0.8, so that divided by 2 is just 1. So the change in price was 40 cents, and it decreased. So negative 0.4, that's my change in price, over the average price. The change in price is the change from this to this, and then the average. So let's do the math now. So the top divided by, I get negative 0.5, and remember we typically ignore the negative, so it's 0.5. So it's less than 1, so we say it's inelastic if you were asked that question. The price elasticity of demand for a product tends to be greater, so we tend to be more elastic. We talked about this. What are the factors? When at a lower price? No. We tend not to care at lower prices. Remember the pack of gum example? We're more elastic, so more sensitive to price, when more greater, the more broadly the product is defined. The fewer close substitutes, no. We tend to be less sensitive the more close substitutes there are. We tend to be more elastic, more sensitive when there are more substitutes. Yeah. 5. Suppose you are advising the government on changes in the gasoline market. Okay, so we're advising the government, gasoline market, got it. The current price is $1, and the long run price elasticity is 0.8. So our price elasticity of demand is 0.8. If a tax on gasoline causes the price to rise to $1.50, then the quantity demanded is predicted to fall in the long run by how much? Okay. So let's take a look. So we know that the formula for this would be percentage change in quantity over percentage change in price. And what do we have? We have the elasticity as 0.8. We have the price before and after, so we can actually expand this into the denominator. Remember that this is change in price over average price. And then the percentage change in quantity, we don't actually have any quantity numbers, so we can't really do that one. So this is how I would break this up. If they give you the elasticity and they give you information about price and quantity, then you would use this formula, like I did here. But if they only give you information about price, then you can only do it for price, and you have to leave quantity kind of in its less expanded form. So we get 0.8 equals the change in quantity is actually what they're looking for. So that's another hint that you should leave that as it is, because it said the quantity demanded will fall by how much. And then for change in price, the price change was 50 cents. And the average price is $1.25. $1.25, if I add up 1 with $1.50, it's $1.25. So let's see what I can get here. I'm going to take this whole thing and multiply it into the 0.8. %. I get a 32% change in quantity. And expenditure will rise. Well, here, I mean, the answer is obvious because there's only one with 32%. But to actually answer the question, you need to go back to what I was saying before. When demand elasticity is less than 1, then price and expenditure go in the same direction. When we're inelastic, price and expenditure will go in the same direction. So here, where is it? If we're increasing the price, then people will spend more. If we're increasing the price and it's inelastic, total expenditure will rise. Number 6, if the demand for goods fluctuates but the supply curve is stable, then which of the following combinations would generally yield the greatest quantity fluctuation? The demand for goods fluctuates, but the supply is stable. Okay, so basically they're saying you have supply and demand. Supply is actually not going to move, but demand will. So demand is going to shift. What would cause the largest change in quantity? So if demand were to move, let's say, to the right, we can see that that is going to cause a change in quantity equal to the gap between those 2 points. So the question is essentially asking you, what is going to cause the largest increase? And it's talking about demand being elastic or unit elastic. So remember what inelastic just means that it's steeper. And elastic means it's flatter. So let's take a look. If there's I'm going to go to a new page because I want to explain this to you guys both conceptually but also graphically. Okay. So supply is either going to be inelastic, elastic, or unit elastic. Got it. So if there's a change in demand, so if, for example, if there's an increase in demand, we know that that's going to cause an increase in price. So what is going to cause the largest change in quantity? Well, that means that we need quantity supplied. That means that we need supply to be very sensitive to changes in price. Because we know that the more sensitive it is, the more it will increase. So that's what elasticity is. The more elastic the supply, then the more the quantity supplied will increase as a function of a change in price. So I think I like elastic for this one. But now, would it be a small demand fluctuation or a large one? I would say a large one because the more it fluctuates, the more the price will change. But now we can look at it graphically. So let's say I make demand elastic, what I'm saying. So it's pretty flat. We'll do two side by side so you guys can see. And then we'll make our demand kind of like this, whatever. This is demand, this is supply. And let's shift our demand this way to D2. So look what happens to the quantity. Right? The quantity moved this much. So the more I shift my demand, the more that quantity will move. So that's why I like a large demand fluctuation versus a small one, right? Because the more it fluctuates, look, if I shift this even more, you could see that the quantity will be shifting more. But now for the elastic versus inelastic, I'm going to draw this again, but I'm going to change the slope of supply so we can see. I'm going to keep the exact same graph so we know that we're comparing the same things, but I'm going to make it steeper. You see, oh, hold on, I didn't want to delete the demand though. Hold on, I'm going to back up a little bit. Okay, good. Bear with me. I'll have a nice graph after the screen to copy. Okay, so look. I'm going to erase the supply curve, and I'm going to draw another one going through that same first point, but that is much steeper. So now look. The exact same shift in demand, sure, it caused a change in quantity, but was it as much as before? Right? Let's take a look. The same shift in demand, because the supply was steeper, caused a smaller change in quantity. So I like my answer. We want a flatter supply curve, meaning more elastic, and we want a large shift in demand. And that would cause the largest fluctuation in quantity. And again, if I go back conceptually, this causes this. So the change in demand causes a change in price. And then the more elastic something is, the more it'll react, the more the quantity will react to a change in the price. Okay, so one that really required a lot of thinking. I love graphing these types of questions, though. Don't be shy to ask questions. Yeah, of your own if something's not clear. Number 7. Suppose an increase in demand, so that's a shift in demand, for web design services in Canada increases the price from 95 to 105. And so, and then the hours of service delivered increases from 4 to 8. Which of the following can you conclude? Well, let's just punch it in, right? Let's do the math. So elasticity of demand we know is going to be the change in quantity over the average quantity divided by the change in price over the average price. So the change in quantity here is 400,000. And the average quantity is 600,000. That's the midpoint between them. For price, the change in price is $10. The average price is 100. So if I'm doing this, I would get 6.66. So this is more than one. We say demand is, it's not perfectly elastic, but it is elastic. You could have also probably done this more conceptually. You can see clearly that the percentage change in quantity was much, much greater than the percentage change in price. Look, price changed by $10. $10 is about, just over 10% of the original price. But the quantity doubled. You had a change in price that was about 10%, but a change in quantity that was 100%. So it's elastic. 8. Suppose an increase, so this is similar. But this time we actually want to measure it. So we have the answer to this. It's what I did here. Okay. Now taxes. There's not that much to know here, but what there is to know is very important. So an excise tax, first of all, is a tax that is applied to a particular product, and it's typically a fixed dollar amount. So we often see this on things like cigarettes and gas. Let's say you buy a pack of cigarettes, hopefully you're not, and you have to pay a tax of $1 per pack, or maybe 50 cents per liter of gas, or something like that. When the government imposes this type of tax, we often think that it's the consumer that's paying for the tax, but in fact, it's both the consumers and the suppliers that are paying for the tax. They share the tax. But there are certain cases where the consumer will pay more of it, and there are other cases where the supplier will pay more of it. And it's important to understand why, how, first of all, like how does the supplier pay the tax if I'm paying it when I go to the pump? And what are the factors that would make it be that the consumer is going to pay more or the supplier is going to pay more? So first of all, what you want to understand, if I were to show this on a graph, you have your supply and you have your demand. And let's assume we're here at the market clearing point. And let's do gas, okay? So let's say the price of gas is $2 a liter. And at that price, people are willing to buy, 1,000 liters a day, right? If you at a particular gas station or whatever. Now the government comes in and says, okay, we're going to add a tax of 50 cents. Well, the price of gas will not go up by 50 cents. And that's often what we think. Gas will become more expensive. But we talked about this, how a tax will actually decrease the supply. So my supply is going to shift to the left, and it's going to move to this point here. So my equilibrium will be here. And let's say that point is $2.30. And at that price, we sell, 800 units. Well, this would be $1.80. This is what happens when you impose a tax. There's going to be less gas purchased because for two reasons. One, gas became more expensive, and so demand goes down. And because of the tax, gas stations will make less money, and so they want to supply less. So you have a movement here on the demand curve. You have a shift in the supply curve. This point right here, this is the new consumer price. By the way, I made all these numbers up, but it's to show you the effect. And down here, the 180, that's the new supplier price. So when you go to the pump and you pay $2.30, the gas station has to take your $2.30 and give 50 cents to the government. So they only get to keep $1.80. So if I zoom in here, for the consumer, the price went up 30 cents. For the supplier, the amount they get went down 20 cents. I want this to sink in, okay? A 50-cent tax caused the price that the consumer pays at the pump to go up 30 cents, and it caused the price that the gas station gets to keep to go down 20 cents. So these here are the splits. Consumers, out of the 50 cents, consumers are paying 30 cents more. So the consumer is paying 60% of the tax. And the suppliers are paying 20% of the tax because, 40% of the tax because they're losing 20 cents on a 50-cent tax. So this is what we call the consumer and the producer tax burden, or the tax incidence. It's really just what percentage of the tax is paid for by either party. Now, I have a formula here. I don't think you really need to know it, but it's useful. If you take the elasticity of supply divided by the elasticity of supply plus the elasticity of demand, making sure you're using absolute values there, this is going to give you the consumer's tax incidence. That'll give you the portion of the tax the consumer will pay. But what I care more about is you just understand what I'm going to say next. The side that is less elastic will always pay a greater portion of the tax. The more inelastic you are, or the less elastic you are, the more of a tax you will pay. So let's say the example here. The consumers are paying a greater portion of the tax than the supplier. That means that the elasticity of demand was lower than the elasticity of supply. So let's summarize this, okay? I think this is good. If the elasticity of demand is less than the elasticity of supply, the consumers pay more. Pay a greater portion of the tax. They're going to pay more of the tax. But if the elasticity of supply is smaller, then the producers will pay a greater portion of the tax. This is really what I care about. This, honestly, it's not even in the textbook, but it's still something useful that sometimes students like if they're more like they want a formula for something. There it is. This tells you the consumer's tax incidence. This is what I care about. So let's take a look at some questions. Consumers will bear a larger burden of the tax. We just talked about this. So when will consumers pay a larger burden of the tax? When they are less elastic. So demand is relatively elastic? No. Demand is relatively inelastic and supply is relatively elastic. I like B. So they're basically saying that demand is relative to supply more inelastic. So that's the one. Saying that both demand and supply are elastic or inelastic doesn't help you. And the tax collected, but that doesn't matter. It's really comparing the elasticities. Number 2, consider a tax imposed on a daily parking charge in downtown. Okay, before the imposition of the tax, the equilibrium price was $15 and 100 cars parked. After imposing a $3 tax, the market equilibrium adjusts to $16. So it's like I showed you. You imposed a $3 tax, but the price of parking only went up by $1. And the quantity went down to 95. How much tax revenue does the government make? If you get asked this question, tax revenue, very, very simple. It's the tax times the quantity. So the tax is $3 and the quantity adjusted to 95. The government is going to make $285 in revenue here. So see. Same question. This time, which of the following statements is true about the burden of tax? So what I want to bring your attention to is what I was saying. Before the tax, the price consumers were paying to park was $15. After a $3 tax, the price went up by only $1. So the consumers are only paying $1 more. That means that the suppliers are actually paying a greater portion of the tax. Consumers are paying $1 out of the $3. So the consumer is paying 1 out of 3. So they're basically paying about 33% of the tax, which means the suppliers, in this case, the supplier would be whoever is the supplier of the parking, they're losing or they're paying 2/3 of the tax. So they must be less elastic than the other ones. Without even looking at my options, this is what I observe. So now I go check. Supply is less elastic relative to demand. Yes. Therefore, more of the burden falls on the consumer. False. More of the burden is falling on the supplier. Supplier is more elastic. No. Supplier is more elastic. No. Supplier is less elastic relative to demand. Yes. And therefore, the burden will fall on the seller. It all goes back to this. Oops. To this. Okay, so there have been proposals that a tax be imposed on sugar-laden soft drinks in an attempt to reduce their consumption. Assume for simplicity that all bottled soft drinks are the same size. Suppose the initial market is at $2 and 1,000. So the initial market is right there at that point. And then we impose a 60-cent tax. So you can see that this basically shifts up by exactly 60 cents. But the price that the consumer pays only goes up 40 cents. I'm comparing there to there, right? They were paying $2 before, they're paying $2.40 now. The answer is D. Okay. Now, there's only a little bit left in this chapter. There are other types of elasticities. The ones that we look at in this class are income elasticity, cross-price elasticity, and that's pretty much it. So income elasticity of demand looks at the relationship between your income or changes in your income and your demand. So if my income were to go up by 20%, what would happen to my demand for things? We talked a little bit about this in the supply and demand chapter, that your demand for certain things would go up and your demand for other things would go down, but we're going to expand on that. So you have two broad categories. When your income elasticity, I'm going to use the symbol like this, is greater than 0, we're talking about normal goods, meaning that as your income goes up, and the symbol we use for income is typically Y, your demand will go up. And if your income elasticity is negative, or less than 0, we're talking about inferior goods, inferior. So as your income goes up, your demand goes down. This is what we spoke about a little bit in the supply and demand chapter, but now we're tying it to elasticity. But within normal goods, we have two categories. So here, let me draw it differently. Okay, this timeline represents your income, this number line represents your income elasticity. This is 0. Anything less than 0 is inferior. Anything more than 0 is normal. Now within normal, you've got another split. Between 0 and 1, we call these necessities. Things that you need. And then after 1, we call those luxuries. So something that has an income elasticity of, let's take bread, right? Bread would be a necessity. The more money I make, the more bread I will consume, okay? But it doesn't mean that if I make 10% more money, I'm going to all of a sudden start buying 100% more bread. I'm going to buy more bread, sure, but just enough to live, just enough to satisfy my needs. But for luxuries, this is where we get into an elasticity that's much higher. So if I started making 10% more money, maybe I'm going to spend, maybe I'll go on 20% more trips, or I'll buy 40% better car, something of that nature. So just know that the splits here. Negative is inferior, positive is normal, but within the normal, you have necessities between 0 and 1, and then anything over the 1 would be luxuries. And the formula is actually pretty much the same thing. If I compare it before, remember it was change in quantity over change in price divided by, change in quantity over average quantity. Change in price over average price. We're just changing the denominator, because now instead of it being price elasticity, it's income elasticity. So I'm changing the factor to income. Then you have cross-price elasticity, which is looking at how does the change in the price of one good affect the demand for another good. So it's not regular price elasticity. Just regular price elasticity is we're looking at one good. The price of cheese and the demand for cheese. The price of tables, the demand for tables. But cross price elasticity is we look at the price of one good versus the demand of another good. So what happens to the demand for tables as the price of chairs goes up, for example? So what do you need to know here? When you have a positive cross price elasticity, we say the goods are substitutes, because as the price of good, we'll say good X, goes up, we're going to buy less of good X, but we're going to buy more of good Y. So when there's a positive relationship between the price of X and the demand for Y, we say they're substitutes. We're buying Y instead of X. And when it's negative, it means there's a negative relationship between the price of X and the demand for Y. A negative relationship. So meaning they go in opposite directions. Here, let me stay consistent with my arrows. So if the price of X were to go up, we're going to buy less X, right? The basic theory of demand. Well, if we're also buying less Y, it's because X and Y go together, gas and cars, for example. So when there's a negative relationship between the price of X and the demand for Y, we say they're complements. X and Y go together. The formula, same formula. But again, we're looking at the cross price. So you're looking at how does a change in the price of one thing affect the demand for the other thing. So let's do some examples. Income elasticity of demand measures the extent to which what? Let's go through the options. The price of a good changes when there's change in income. It's not the price of good, it's the quantity. The quantity demanded of a good changes when income changes. That's the one. If a product's income elasticity is negative 1.7, so negative, remember this means that there's a negative relationship between your income and your demand. So they're talking about inferior goods, something that you will buy less of as you make more money. An increase in income will lead to an increase in demand. False. A decrease in income will lead to an increase in demand. This is true. There's an inverse relationship. If the income elasticity is 2.4, a 10% increase in income will do what? Well, remember what the income elasticity formula is. It's the percentage change in quantity over the percentage change in income. So if I'm telling you that this is 2.4, and I tell you that your income goes up 10%, you just have to cross multiply here. So you see that your percentage change in quantity would be 24%. So there'd be a 24% increase in quantity demanded. Number 4, consider the income elasticity of demand for an SUV. Income elasticity for an SUV. Okay, an increase in income will... Okay, well, if income goes up and SUVs are normal, then demand will go up. This is if they're normal. And if income goes up and demand goes down, it means it's inferior. So let's see what our options are. So an increase in income elasticity will cause an increase in demand if SUVs are inferior. This is false. This will cause a decrease. Will always increase demand? No. Will increase supply? No. Will decrease demand? Will increase demand if it's normal. So the best answer is E. The others are trying to confuse you. That's what we said, right? 5. Suppose the cross elasticity of demand between two goods, X and Y, is negative. Okay, remember what we said. When they're negative, it means the goods are complements. There's a negative relationship between the price of one and the demand for the other. So if they're negative, it means they're complements. So if the price of X decreases, the demand, the quantity demanded for X will go up. And because they're complements, we're going to buy more Y as well. So the quantity demanded will rise for both. Basically, we're going to be buying more X and more Y. 6. Suppose the cross-price elasticity of demand between raspberry jam and strawberry jam is 7.5. 7.5. So they're is positive, so there's substitutes. And remember what it means. So cross price elasticity is basically saying that if the price, we're talking about the price of strawberries. So if the percentage change in the quantity of raspberries divided by the percentage change in the price of strawberries, they're saying that is 7.5. So let's go through the options. A 10% increase in the price of strawberries. So let's say this is 10%. What would happen? If this is 10% and the elasticity is 7.5, if you cross multiply, there would be a 75% increase in the quantity demanded of raspberry jam. So a 10% increase in the price of strawberries leads to a 7.5, false. A 10% increase in the price of strawberry jam leads to a 0.75, false. We're looking for 75. 10% increase in price causes a 75% increase in the quantity demanded of raspberry jam. Remember, elasticity is just a ratio of those two things. Okay, last question. Suppose the price of apples at a local market rises from $2.95 to $3.05. And as a result, the quantity of oranges purchased increases from 39 to 4,000. What is the cross price elasticity? So we're going to start with we'll use our formula, change in quantity over average quantity, but this time we have the quantity of oranges, I'll put O here, and we're looking at the price of apples. So change in the price of apples over the average price of apples. So the change in quantity is 100. There's a 100 unit increase in oranges, and the average is 4,000. Okay, again, this is just taking those two numbers and dividing by 2. For the price, the change is 10 cents. And the average is $3. So let's see what we get. 0.75. So C. All right. So that's it for the elasticities chapter. Again, it's important. The formulas are pretty similar. It's important to understand each type of elasticity, the relationships that it tries to evaluate. If you have any questions at all, you know where to reach me. Email is good. Instagram is good. Discord, if you're on it, is good. Okay. I will see you next time.